I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Yesterday we talked about functions. Some relations are functions and some relations are not functions, and we talked about the vertical line test. One line straight up and down will tell you if it's a function. If you have a picture, take the ruler, hold it straight up and down, and if you touch more than one point on that function, then it's not a function. Circles are not functions. Triangles are not functions. Most lines that don't go straight up are functions. The other thing we talked about was the exponent of the y always has to be 1. And we talked about they give you the set that you can only have one domain go into the same range each time. The x is the domain, the y is range. We talked about that. We didn't talk about how to get points to graph them. We graph these, we call these t-graphs. We're still working with a.1.apr.a.4, which is add, subtract, multiply, and divide rational functions and equations. I know what is and is not a function. I kept that from yesterday, but it's still on your I can statements. I can use function notation. I can find elements of a function on a t-graph. That's yesterday's video. I'll try and post this one soon. A t-graph is an XY table, is how we get a point or points. How many points do we need to graph a line? We need at least 2. How many will I get? I'll get 3. Because if I get only 2, and they're supposed to look like this, but they look like, one of them looks like this, how do I know if I've made a mistake? But if I get 3 points and they are linear, if they all line up, then I'm sure that's where my line goes. You get to choose the x. Now, you probably don't want to graph 1776, 1492. It's way off my graph. My graph only goes to like 8 or 10. You probably don't want to have to multiply one of those numbers by 2 and add 1. Here's our equation. We are going to add 2. We're going to add 2. No, we're not going to add 2. What are we going to add? What are we going to do with 2? We're going to multiply with 2. We're going to add 1. You ask yourself, what are we doing to x, the variable, our domain x? What are we doing to it? We're multiplying by 2 and adding 1 in that order. So we're going to take our domain here. Minus 1 times 2 is minus 2, plus 1 is minus 1. We're going to put in 0. 0 is the easy one. I always get 0 because when x is 0, it's not there. So 2 times 0 is still 0. And we add 1, we get 1. If we put in 1, look at my pattern. Minus 1, 1. I think I got a pattern. I think this should be 3, but let's check it. 1 times 2 plus 1, 3. And I think this one would be 5, but let's check it. Let's put the 5 down there. 2 times 2 plus 1 is 5. Now, we have these points. And we'll talk about making sure you know how to graph those later, but believe me, they will all show up in a line. Here's my next equation. Y equal minus 2x. We're going to take our x. And once again, you can make the domain x anything you want. I could have put 1492 in there. But when I multiply 1492 times minus 2, I got to have a graph that goes 3,000 spaces this way and this way. And I don't want that. So I usually get minus 1, 0, 1, 2, unless there's some other reason for me to change that. So minus 2 times minus 1 is 2. 0 times minus 2 is 0. 0, 0 is on our graph. Minus 1, 2 is on our graph. And I think I got the pattern now. I'm going down to 1 times minus 2 is negative 2. And 2 times negative 2 is negative 4. Since these are linear equations, there ought to be a pattern in that t-graph. And we'll talk about graphing those again later on in another video or maybe tomorrow. Here we go. Here's the next example I have. Y equals negative 2/3 x. And if you ask yourself, the whole algebra is about what are we doing to x and how do we undo it? What we're doing to x is we're multiplying by 2 and dividing by 3. One of those numbers has to be negative. I usually keep the negative with the 2, but you could do it with the 3. So we're going to put in some numbers. Hey, minus 1 times minus 2/3 is a fraction. And some of my students, they don't like fractions. I think they all understand fractions. They just hate fractions. So I'm going to put in numbers that will make sure that my fractions cancel out. Minus 3, 0, 3, and 6. Why did I choose those numbers? Because when I divide them by 3, they're going to come out even. It'll get rid of our fractions. Because I really don't want to plot 1 and 2/3 on my graph. I want whole numbers on my graph as much as possible. Probably not true when you get to algebra 2, but now we want whole numbers. All right, minus 3 divided by 3 is minus 1 times minus 2 is 2. 0 times any fraction is 0. 3 divided by 3 is 1 times minus 2 is negative 2 or minus 2. 6 divided by 3 is 2 times minus 2 is negative 4. Do I have 3 points? Yes, I do. Am I worried about leaving that blank? No, I'm not. I've got more than 3 points. I've got 4 of them. This is domain once again. This is domain. This is range. I've got 4 points. I don't need a 5th point. Let's try another example. Y equal x over 5. Or y equals x divided by 5. You can say it either way. I'm going to have my x in this column, and I'm going to have my x in this column and my y in this column. Now I'm going to take numbers and divide them by 5. I really don't want to graph negative 1/5. So my numbers I'm going to put in here are minus 5. I want numbers that 5 goes into them. 0 and 5. Now, I should get rid of all my fractions now. Minus 5 divided by 5 is negative 1, minus 1. 0 divided by anything is 0. 0 on the top is 0. 0 on the bottom is a big mess we don't want to get into. And 5 divided by 5 would be 1. I now have 3 points on that graph. I line them up. If the 3 points don't line up, one of the points is wrong. But if all 3 points line up, take your ruler, draw your line. Here's my last one, and I'd like you to try it right now. You do this. I'm going to put X, and I'm going to put Y in, and I'm going to give you the really easy stuff. I'm going to give you minus 1, 0, 1, 2. Put that in, and in a minute we'll see what you've got in the Y column. Now we need to make sure that we can graph this. Let's go back to our first example. We said that y equals 2x plus 1. We multiplied by 2. We took our domain, multiplied by 2, added 1, and we got a range. If the domain goes into the machine, the range comes out. Now, what do we get? We got -1, -1, so I'm going to put that on a graph. -1, -1. Goes right about there, right? No, that's -1 plus 1. Let's put it down here. -1 back, -1 down. Then we went through 0, 1. Let me get a different color here. Let me get the blue. And let's put this blue at 0, 1. That's 0 out, 1 up. 0, 1. Let's get the orange now. Let's put the orange at 1, 3. 1 out, 3 up. As you can see, my orange, my blue, and my green line up. You can take a ruler and go right down those. What's the other one? 2, 5. Let's put the black dot up at 2, 5. This is 2 out and 5 up. And as you can see, we got an extra point. All 4 of my points line up. Two, 5. 1, 3. 0, 1. They all line up. That's how we're going to graph these. Let's do one more. Let's go down to this one. Let's get my little dots off the graph so we don't confuse. When you get to Algebra 2, we'll let you graph 2 points at one line. When we get in April, we'll let you graph 2 equations on one graph. Right now, you're in Algebra 1. Let's try and keep it simpler than that. We're going to put a dot at -1, 2. Start at the origin, of course. We go back 1 and up 2. -1, 2. Then we go to 0, 0. Then we go to 1, -2. 1 out and 2 down. As you can see, I've got another point, but I don't need to graph it. I've got 3 points. They form one linear line. Now, are there other points on the line? Yes, lines go on and on and on forever. My graph might stop at 5 up here, but this line goes on and on and on and on forever in both directions. So you can get as many points as you need, but right now we only need those 3 to draw our line. And that's how we're going to graph these points once we have a completed t-graph. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.